Hello my dear students, how are you all? Welcome to the Karnataka YouTube channel. I hope all of you are doing good. We are starting again your PU1 portions. Today's chapter of discussion is going to be KCET maths, of course, for PU1, as I said, master stroke for a chapter straight line. Okay, so we'll discuss this chapter bacha very quickly and we'll start with the session. I know your time is very important, so we'll not waste any minute of your time. Let's start right away. So what we have right now, please check. So we have here distance between 2 points. Okay, very important. What is it? The simplest formula of all. Okay, I know all of you know it. We have learned this in grade 10 already, sir, but still, let's see this over here. 1 second you can give me. If you have 2 points known like this, point A with the coordinate of x1 y1, okay, and point B with the coordinate of x2 y2. Okay, I'm not talking about the 3D space, not the z-axis, only xy is good enough. Okay, then what happens is this formula is given by the distance AB is given by, please check, x2 minus x1 the whole square plus y2 minus y1 the whole square. That's simple. Okay, x2 minus x1 the whole square plus y2 minus y1 the whole square. If you have a z-axis, what will happen? It will become plus z2 minus z1 the whole square. I hope this is clear. Okay, I hope this is clear. Okay, chaliye. Now what else we have? Let a point M divides the line segment. Okay, we are talking about bacha section formula. Okay, basically same thing we'll take here. If I have a line over here, A, B line, okay, the coordinates are given again, x1, y1, and over here we have x2, y2, and there's a point on this line, let's call this to be P, such that AP is nothing but of section M, N. Means AP to BP is nothing but M to N. In that case, what happens is I can write a formula for the coordinates of the point P in this fashion. Please check. So your x will become, bacha, please check, mx2. So x will become mx2 plus nx1 upon m plus n. This is the value for your x, okay, and this is the value for your y. I hope this is clear. I hope this is clear. Same way, if you have, this is the case when you have internal section. If you have bacha external section means basically if the point A is over here, point B is over here, and the P is outside this part. So this is going to be your section M, this will be your section N. The coordinates remain same, of course, it will be x1, y1, for B you'll have x2, y2, and for P you'll have x, y. So this is called as the case of external section. External section. When you have that, the coordinates become simply, the minus sign is introduced over here. So mx2 minus nx1 upon m minus n, this is going to be your x coordinate. Same goes over here, my2 minus ny1 upon m minus n. Okay, please check. See here, so if you check carefully, this is your point A, this is the point P and point P. Same fashion over here, we have A, we have B over here, and we have P outside. Okay, now midpoint is another case of, a special case of your section formula. Whenever this section is bacha equal, whenever you have the section M equals to N, whenever you have section M equals to N, whenever in the case of internal section you have M equal to N, this transform into midpoint formula. Check here, M is 1 means M, x2 will be left, N is 1 means x1 will be left. We have become x1 plus x2 by 2 for x, okay, and for y will be bacha y1 plus y2 by 2. I hope this is clear. Okay, let's move on now. Now next one is on the area of triangle. Again, very simple concept. Please check here. Half of x1. How do I remember, sir? First write half. This because of the we want only positive value for the area. Okay, now check this out. Right here x y minus y. Okay, please put here plus sign again. X y minus y. Put another plus sign. X y minus y. Put the modulus. Now write this in this order. Please check. Okay, 1 2 3 2 3 1 3 1 2. Please check. That's how I remember it, bacha. X y y. Okay, and then put here 1 2 3. We have 2 3 1 and we have 3 1 2 as well. Okay, we have 3 1 2 as well. This is the formula for your area of triangle. Of course, if the let's say the points, for example, if ABC is making a triangle, right, and somehow you are trying to get this A on the line AC, okay, sorry, on the line BC. So you'll have the case now as BAC. Whenever you get this points as collinear points, this is also called as collinear points, okay, please check. Then what happens? Your area will become equal to 0 because it's a one, it's not a 2D figure anymore, it's a 1D figure. It's a straight line, right? It's only one dimension, it's a length itself, okay. So what is going to be the area of this part? Nothing. So a 0 simply. Please check here. So area of triangle will become 0 if the points are collinear, okay. A lot of questions can be asked on this. If you have seen your boards paper, questions is there, okay, on this particular topic. Now we have in K-Hub, the knowledge hub today, what we have. Let ABC with vertices x1, y1, x2, y2 and x3, y3 whose sides are ABC. Basically, triangle is there, right? Okay. A, B, C. Okay. The vertices are x1, y1, x2, y2 and C, x3, y3. Okay. And the sides are called what, bacha? This side will be your side A. Opposite to the angle A will be side A, side B and side C. Okay. Then we have formulas for in-center, formula for centroid, and we also have two more formulas for circumcenter and orthocenter. Okay. I know they're big formulas, but they're very, very easy to remember. What about this, sir? For in-center, ax1 plus bx2 plus cx3 upon a plus b plus c. What is ABC, bacha? ABC is the sides. Okay. So ax1 plus bx2 plus cx3 upon a plus b plus c. Same way you can write for y also, na? ay1 plus by2 plus cy3 upon a plus b plus c. Isn't the formula very simple actually? Extremely simple, bacha, for the in-center. What about this? This we know, na? For centroid, x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. Acha, one more thing, there is a derivation for all of this, but not required for us. If you know the formula, that is good enough for us, okay? There is a derivation for this also is there, okay? But we don't need it, okay? I know, most of you will know this derivations for both of them, but don't require, it's not required for us right now, okay? So let's move on now. For circumcenter, what we have, bacha? We have in the terms of sine 2a, and for orthocenter, we have in terms of tan a, sir. Please check. x1 sine 2a plus x2 sine 2b plus x3 sine 2c upon sine 2a plus sine 2b plus sine 2c. Same goes in the case of y. y1 sine 2a plus y2 sine 2b plus y3 sine 2c upon sine 2a plus sine 2b plus sine 2c for the case of circumcenter. Okay, circumcenter. Chaliye. Now orthocenter, please remember this as well. I hope you know what is in center. Okay. What does it mean? Circle is inscribed. Okay. What about centroid, bacha? The intersection of the midpoints, right? Point of intersection of angle bisectors. That's your in-center. Okay. Medians. What is this going to be? Circumcenter. Circle is circumscribed. Okay. Please check. Orthocenter, bacha. What is it going to be? Intersection of all the perpendicular bisectors. Okay. So basically altitudes. It's called as orthocenter. Okay. Formula is x1 tan a plus x2 tan b plus x3 tan c upon tan a plus tan b plus tan c, and same goes with y1 tan a, y2 tan b and y3 tan c upon tan a plus tan b plus tan c. Yes, only formula is relevant to us. Let's move on now. Now next is going to be we are in the straight line, so let's start from the first thing which we have to know, something called as slope of a line. So how do you find which is slope of a line? Remember, so I can have slopes in two ways. Okay, one way is when the line looks like this. Okay, other way when the line looks like this. Won't you all agree, right? In this case, if you check the angle with the x-axis, if of course you take in the direction of counterclockwise sense, goes like this, you get this as theta, you get this as theta as well. Okay, and the slope given by the variable m is nothing but tan theta, is nothing but tan theta. In this case I have taken theta 1, so let's say theta 1. One thing we know for sure, over here we have acute angle, so it will be positive slope. This is going to be a negative slope. Okay, not relevant right now, but just wanted to explain you anyway. Okay, great. So what is there? Slope of a line when coordinates of any 2 points of the line is given. Okay, basically for any given line you have 2 points, coordinate is known. For example, x1 y1, x2 y2. How can you find slope? How can you find slope, sir? Very simple. Slope will become, please check, x2 minus x1, sorry, basically difference in the y coordinate first upon difference in the x coordinate, sir. So y2 minus y1 upon x2 minus x1. You can write this as x1 minus x2 also. Basically you can write this as y1 minus y2 upon x1 minus x2 also will remain same. Okay, y1 minus y2, I'm asking you to do this, y1 minus y2 upon x1 minus x2 will remain the same. But don't take y1 minus y2 over here and take x2 minus x1 over here. If you're writing y1 here first, write x1 here first. I hope this is clear. Okay, next what we have, slope of the line lx plus my plus n. So of course bacha, remember this form, convert this into this form that we know, y equals to mx plus c, y equals to mx plus c. Okay, one second, y equals to mx plus c. If you take this form, no, of course what is going to be the bacha slope? If you write this over here, you're gonna get this as my equals to minus lx plus, okay, plus c. So if you take the m on this side, you get y equals to minus l by mx minus c by m. What is the slope then? Minus l by m. Please check. Okay, basically negative side of coefficient of x upon coefficient of y. What is l bacha? Coefficient of x, and what is m, sir? Coefficient of y. Okay, slope of a line equally inclined with axis is going to be either plus 1 or minus 1. Okay, why, sir? Why this bacha? Please check. So if I'm taking this equally inclined means like this, no? This is the meaning of equally inclined with both the axes. This will be again 45 degrees. This will be again 45 degrees, which is nothing but theta over here. What I get, bacha? Tan 45. How much is this? 1. If I take the other way in this quadrant, this will be again 45. This will be 45 again, equal inclined, है ना? So this whole angle will become, bacha, how much? Theta will become 45 plus 90, so 135, and tan theta will become in this case minus 1, because second quadrant, na? Second quadrant, minus 1. Right? What is this? 135. Please check. Because 90 plus 45 will be 135 only. Okay, that's why plus or minus 1. 3 points A, B, C are collinear if and only if slope of AB equals to BC. Of course, right? If I take this line, I'm talking this at collinear, bacha. It means, of course, this slope, if I call this to be M1, call this to be M2 slope, of course they have to be equal, na? They have to be equal, right? Think about it. Equal, because they're the same line actually. Okay, so they have to be equal. Even if they are parallel, bacha, what will happen? They'll be equal only. Let's move on. Angle between two lines. Okay, very important concept. Please check here. So there's a formula for this. This is the formula. M2 minus M1 upon 1 plus M1 M2. 1 plus M1 M2. Remember, this is something coming from the trigonometric functions we have learnt, right? Tan theta minus tan theta, tan alpha minus tan, what is it? Tan A minus tan B upon 1 plus tan A tan B. Something like that. Okay. Achha, one thing I want to tell you, what is it going to be? So, bacha, basically M1 represents your slope of the, let's say, line L1, and over here to the line L2. Okay. M1 is your tan theta 1 and M2 is your tan theta 2. Of course, slope of the line 1 and line 2. Okay. So theta will become simply what, bacha? Tan inverse of the given fraction. Again, both plus minus sign is there. Okay. If you take in this angle, what will happen? This will be only, please check, positive section you can take. Okay. M2 minus M1 upon 1 plus M1 M2. M1 minus M2 upon 1 plus M1 M2. Okay. Now over here, very important. If lines are parallel, sir, then theta will be 0. Of course, right? Parallel means theta is 0. What happens in that case? You get this part as 0. So you can become what, bacha? M1 equal to M2. Please check from here. You get this as 0 equals to this big fraction, na? Right? So from here you get M1 equals to M2. M1 equals to M2. Please check. Please check. Alright, for parallel it is equal. The slopes will be equal. That's what I was saying. Now in the case of your perpendicular, okay, the slope of parallel lines are always equal. Already said that. Great. If the lines are perpendicular to each other, of course, then it means that it's going to be 90 degrees. What will happen in that case? Tan 90 will become undefined. Okay, basically 1 upon 0. So check here, this part over here, no, this part, this will become 0, sir. How can this fraction, think about it, how can this fraction m2 minus m1 upon 1 plus m1 m2 should be equal to this, right? Basically undefined, right? Basically undefined, right? So of course this part has to be 0. So from here we get 1 plus m1 m2 as 0. It means, bacha, basically check here, m1 m2 is minus 1. From here we get m2 equals to minus 1 by m1, minus 1 by m1. Okay, done. Please check, same thing written over here. If lines are perpendicular and slope of one of the line is m, then other line will be slope having the slope minus 1 by m. Please check. Slope of a straight line equally inclined to two given lines. Okay, when we have two given lines, okay, for the slope is m1 and m2. Let's say I have a line L1 with the slope m1 and I have a line L2 with the slope m2. Okay, then we're looking for a line which is equally inclined to both these lines. So let's call that to be line L with the slope m. Then the result is this. Please check, m minus m1 upon 1 plus m m1. What is this, bacha? Please check, what is this, sir? If I take this, let's say like this. Okay, this is your L2. Think about it. So first thing is nothing but your alpha actually, right? Isn't this? Check from here, it's nothing but tan alpha. Between m and m1 we are finding the angle between the lines. Won't you all agree with me? Between m and m1 we just saw the formula, right? Tan theta, tan alpha will become, what is this, bacha? There's nothing but your tan alpha, right, sir? Hai na? And what is this part, bacha? Nothing but your, if I take this angle to be beta, right, it becomes tan beta, na? And they're saying what? They'll be equally inclined, hai na? They'll be equally inclined. That's why tan alpha and tan beta are equal, sir. Tan alpha and tan beta are equal, sir. Please check. Right, now this is the formula, right? m2 minus m upon 1 plus m2. Have a look. Same formula is being used two times, one with the line L and L1 over here and one with the line L and L2 over here. Done. Chali. Simple concept. Now equation of a line in standard forms. Okay, so few simple things are there. If you remember, if I have, let's say I talk about only x and y axis. Equation of x axis will be, please check here, y equal to 0. First thing, equation of x axis is y equal to 0. Because any point you take on x axis will have y coordinate as 0. That's why we are writing the equation of x axis as y equal to 0. Same goes with y axis, it will become x equals to 0. Because any point you take on y axis, x will always be 0. Okay, the coordinate x will be 0 on all the points of x on the y axis, hence it will be having the equation as x equal to 0. So this is clear. Now if I'm taking a line, please check over here, this is x, this is y. I'm taking a line parallel to x axis, what will become, bacha? Please check, it will become y equals to the constant k. Over here you take, over here you take, doesn't matter. What is the slope here? It will be 0. Slope will be 0. How come, sir? Because actually you're getting theta value as 0. Okay, now if I take this other case, this is your x coordinate, x axis, y axis, and the line is parallel to y axis in this case. Okay, so what I get, it will be x equals to the constant k. Okay, now of course what will happen, bacha? What will happen to slope here? Infinity or undefined. How come, sir? What is the angle over here? Please check. 90 degrees is your angle. If you put 19 tan, what will happen? It will become undefined. That's why it is undefined. Slope is undefined in this case. What is the slope, bacha? It is 0. Another I have already given you for x equal to 0 and y equal to 0 for the equation of the x and y axis. Okay, some standard forms. Okay, useful in the questions. So let's move on now. Now we have some 4 simple forms of straight line. What is the first one? Slope intercept form. Remember this form, y equals to mx plus c. Whenever in the question they have given you intercept and slope, this c is called as y intercept. How come y intercept, sir? Put x as 0, na? Put x as 0. What is going to be value of y? C. Please check. It's going to be value of y. Okay. So we get here y-intercept as c, and m will be your slope. Okay, clear? This is called as slope-intercept form. Whenever this is given, we take that in this form only. Now we have point slope form. Whenever you have a point given and a slope given, basically let's call the point to be x1 comma y1 and slope to be simply m. Then the formula becomes, please check, y minus y1 equals to m times of x minus x1. M times of x minus x1. Okay, please check. Right? Yeah. Okay, this is clear. Next, what we have, sir? 2-point form. We have two. When in this case we still had m given, right? In this there's no m given in this case. What are you gonna do, bacha? In this case, let's say you have only 2 points given, x1 comma y1 over here, and you have other point given as x2 comma y2. The formula will become y minus y2 upon y minus y1 actually. So y minus y1 upon x minus x1 equals to y2 minus y1 upon x2 minus x1. If you look carefully, actually this is same as the slope m. So basically this and this is the same thing. Whenever the slope is not given, you find the slope using this formula, and you use the same condition, y minus y1 upon x minus x1. Please check. So this and this is almost the same thing, actually. Same thing. Okay, let's move on now. What we have last? Intercept form. Whenever you have two intercepts given for both x and y axis, let's call this to be a, this to be b, this to be a, and this to be b. Okay, so if I'm writing, bacha, this equation will become x by a plus y by b equals 1. Basically, if you take y as 0, it will become x equals to 1. Y 0 means this whole thing is 0. I have x by a equals to 1. It means x is a, this is x-intercept. And if you take x 0, what will happen? You'll have this whole thing 0. Y become equals to b. This is your nothing but y-intercept. Please check. Is this clear? Have a look. Done? Okay. Let's move on now. Next we have, sir, in knowledge of today, equation of any line parallel to a given line will be like this. Please check. Remember very clearly, only difference will be, bacha, over here in the constant part. Plus c plus k. Plus c plus k. That's the only difference, okay? Because the lines are parallel, no? So slope will be same, bacha. Slope will be same, sir. But in the case of perpendicular lines, what will happen? There will be difference. Please check here. You can have ax plus dy plus c as a given line. It will become, bacha, minus a. Why, sir? The rule, remember? The rule is m1 m2 equals to minus 1. If you want, you can find the slope from here. What is the slope from here, bacha? Remember, negative side of, we put here coefficient of x, so a, upon the coefficient of y, so b. From here what we get, please check. From here we get negative side of coefficient of x, which is nothing but b, and we get coefficient of y, which is nothing but minus a. So I'm getting here simply plus b by a. So this is your value of m1, value of m2. Put it together, we get m1 dot m2 equals to minus a by b into, what is this, bacha? B by a. What is this? B by a. A and a is cancelled, b and b is cancelled. What I get the answer as simply minus 1. Hence proved, sir. Hence proved, sir. Please check. Is this clear? Is this clear or not? Have a look. This is done. This is done. Okay, so for the case of parallel, we have the same coefficient of x and y, because slope remains same. Okay, but in the case of perpendicular, what do you have? We have a change, bx minus ay, or simply we can write this as minus bx plus ay also. If you check, do one thing, check from here, find a slope m3 from here, okay, and apply this condition, m1 times of m3. You get this result also as minus 1. m1 is over here, please check. m1 is over here. m3 you find from this equation of the line, and you apply this result m1 into m3, you get again minus 1. Let's move on now. distance of point from a line, distance of a point from a line. Okay, so this is a very simple formula, bacha. We're going to use this in one of the question today. P equals to mod of c upon root of a square plus b square. What is c, bacha? C is the constant. Okay, what is a square plus b square? This thing. Okay, in this case what we're talking about, the origin. This is the for the origin. Okay, great. When you're talking about a point, sir, okay, then you'll have a coordinate given x1 y1. What are you gonna do? Check here. You write here ax1 plus by1 plus c divided by the same thing. Basically, you put the values x1 and y1 in the given equation, okay, and divide that by square root of a square plus b square. Okay, remember why mod is because this is a distance, right? All is positive. This mod for the reason distance is always positive. Okay, what next now? The length of a perpendicular from a point. Same thing. ax1 plus by1 plus c. Same thing. Please check. Root of a square plus b square. Same thing, bacha. This is the equation of the line, no? Okay. Moving on now. Distance between two parallel lines. What will happen in this case? You will have only constant difference, no? This and this. Have a look. So write this on. C1 minus C2 or C2 minus C1 remains the same thing. And since the slope is also same, na, write this as 1 plus m square. 1 plus m square. Okay. Very simple. What next now? If lines are given in general form, basically ax plus by plus c1, and we have again ax plus by plus c2. Why this is same, sir? Because they are parallel in nature. They are parallel, bacha. That's why. No change. Same thing. C1 minus c2 upon a square plus b square. A square plus b square. In this case, what happened now? A was actually your a was m, but your b was actually what, bacha? Minus 1, na? Sorry. Yeah, plus 1 actually you can take. It was minus m and plus 1. If you do that, what will happen? It will become 1 only, no? Right? Chaliye, let's move on now. Mirror image of a point with respect to a given line. A very important concept. What happens in this case, no? Whenever, let's say, you have a line like this. Again, equation is given to you. We have ax plus by plus c equals to 0. Okay? And there's a point over here, bacha. Point is, let's say, x1 and y1. x1 and y1. We are looking for the mirror image on this point as x2 comma y2. x2 comma y2. Okay, then this point's coordinate can be found using the relation that we have over here. Please check. What's the relation over here? x2 minus x1 upon this coefficient of x, so a, divided by, again equal to y2 minus y1 upon the coefficient of b over here, again equals to same thing, minus sign 2 times of ax1 plus by1 plus c plus divided by a square plus b square. Basically putting the value of x1 y1. This is given, right? This is the given point. This is the given point, sir. This is the given point. So you put the given point in the equation ax1 plus by1 plus c1 plus c divided by a square plus b square with of course a negative sign. Okay, of course a negative sign will be there, right? Because this line will act as a mirror, no, bacha? This will act as a mirror, right? This distance, let's say this is nothing but distance d. This also will be distance d only, right? It will also be a distance d only. Okay, chaliye. Now what about next one, sir? Now one more thing. If I am finding, let's say, another case, I am taking same concept. I have a point. This is given case again. x1, y1. This is a given point. This is known point. Okay. This is your line also given here. ax plus by plus c again equals to 0. This will act as a mirror, and I'm looking for what in this case? Looking for the foot of the perpendicular. Foot of perpendicular. Let's call this point to be again x2 comma y2. x2 comma y2. What happens? Please check here. Same thing will be there, but without a 2. This 2 over here is missing. Check here, x2 minus x1 upon a, y2 minus y1 upon b, and same thing will be there except for 2. Why 2 is not there, bacha? Because think about it. If you see, no, these two will be equal distance, right? D and D are equal distances. Basically, this point will act as the foot of the perpendicular. Yes or no? Yes. What is happening over here? Please check. So over here, what we are getting actually is going to be an equal distance. Okay. So this will act as a midpoint. This point will become a midpoint. That's why this 2 comes when you're looking for this entire distance from here to here. When this x2 y2 represents the mirror, the image of the point x1 y1, then we take 2 factor over here. But in the case of only foot, we don't take the 2. We don't take the 2 over here. I hope this is clear. Please check. Please check, sir. I'll remove this part. Chaliye, let's move on now. We have some questions to solve. So I've taken some questions, not a lot, but some questions which will help you understand the concept better. So let's just quickly do that. Chapter is very easy, right? Not much is there. Very simple concepts are there. Slope of a straight line which does not intersect x-axis is equal to. Straight line does not intersect x-axis. Basically, parallel to x-axis. Because if you take any other line, no, it will intersect some way, right? So if a line doesn't intersect x-axis means it will be parallel to x-axis. I'll repeat myself. If the line does not intersect x-axis, it means it will be parallel to x-axis. Won't you all agree? Okay. We just saw this cases for straight line. What's the condition for this one, bacha? It will become y equals to a constant c. What's the slope in this case? They're asking slope, right? Remember I said theta was 0 and so is the m also, because m is tan theta, so answer will be option D. Slope is coming as 0. Clear? Okay, let's move on now. What else we have? If line through the point this is perpendicular to the line through the point this, okay, let's do one thing. From the first point you find the slope. Using the first 2 points you find the slope. How do you find slope, bacha? Let's call this to be m1. Remember this formula? We had y2 minus y1 upon x2 minus x1. Let's apply this. 8 minus 6 is 2. 4 minus 2 will be 6. 8 minus 6 is 2. 4 minus 2 will be 6 only, right? How much is the answer? 1 by 3. Great. Same way for the other line that we have. What is that? Please check. It's going to be 8, 12, and the other line is x and 24. Find the slope in this case. Let's take this to be m2. We get here x minus 24 minus 12, right? Excuse me. 24 minus 12, no, same formula. 24 minus 12 upon x minus 8. I get here 12 by x minus 8. 12 by x minus 8. Okay, we know for the perpendicular lines we have a result that we know. What is that? m1 times m2 equals to minus 1. So put the values over there. What I get? 1 by 3 times of, I have here 12 by x minus 8 equals to minus 1. 3 4s are 12. It means 4 equals to minus x plus 8. Okay, let's bring this x over here and this 4 over there. We get here x equals to 8 minus 4, hence x equals to 4. Please check. X equals to 4 is the right answer. Option D is again correct. Done? A simple question, not difficult at all. Very, very simple. Let's move on now. Come on. What we have, the question for the day, the last question of the day from this chapter. Okay, so this chapter gets over here only, bacha. Okay, this is the last of the question that I've taken today in this session. Okay, if P is the length of the perpendicular from the origin to the line 1 upon, okay, from the origin, very important. This word is very, very important. Because if you remember, there were two, three formulas. One from the, between two parallel lines. Then there was for from a point to a line. Then from the origin. Because when you take from point to a line, you write this formula: ax1 plus by1 plus c upon root a square plus b square. This is from any general point. Yes or no? Yes. But in the case of origin, what will happen? This will be 0 because x1 is 0 and y1 is also 0. Correct, na? From origin, what will happen? x1 and y1 is 0, 0. So only we'll have left with plus c upon this thing. Plus c upon a square plus b square. Okay. Now check here from this equation. X by a plus y by b I have. I'll take on this side, because it will become minus 1 equals to 0. Now if you compare this with this form, I get ax plus by, please check, by plus c equals to 0. So from here I'm getting, bacha, your a is nothing but 1 by a, your b is nothing but 1 by b, and your c is nothing but, please check, c is nothing but minus 1. So put your values. This will be your perpendicular. They have given the length actually. The p is the length they have given here. So write this equals to perpendicular. C will become minus 1. So minus 1 the modulus divided by root of. Please check here. Root of 1 upon a square. If you want, I can change this. I'm going to write this in form of capital A actually, okay, just to make some difference. So we are having here A, B, A square and B square. Not a problem, right? Not a big deal. Here also A square and B square. What I get now? Have a look. The A value is 1 by A the whole square plus 1 by B the whole square, giving me this as, please check, equals to P. Simplify from here. Squaring both sides. What do you get, bacha? We get this as, have a look, 1 upon, root will be, now I can, if I square both sides, what will happen? This root will be cancelled out, okay? So I'm going to get this as 1 upon A square plus 1 upon B square equals simply P square. Let's do one thing. Right now I have P square over here. I'm going to take the reciprocal on both sides. I'm going to do what? Take reciprocal on both sides. So I'm going to get, please check, if I take reciprocal of this thing, it will become without this. So this will come in the numerator, this whole thing. It will become 1 upon A square plus 1 upon B square. On this side, what will happen? Reciprocal you are taking. So 1 upon P square. What are they asking? The value of 1 upon P square, right? Result is going to be option number A. Done. Please check. Okay, so this is it for your chapter straight lines. Okay, I hope you had fun. I hope you learned something. Let's start. Okay, so we have sections of a cone. Okay, now check carefully. What is that, bacha? Of course, the chapter is going to be conic section. The name suggests sections of a cone. So what you do over here is you take a double napped cone. Yes, the name is right. Double napped cone you take over here. Okay, and then you try to create some sections accordingly, whether it is perpendicular at some inclination of the angle or in the both section of the cone. As the name suggests, double napping. Okay, this is the upper nap, this is the lower nap. Okay, so sometimes we make a section perpendicular to this axis. Okay, sometimes we make a parallel to the generator axis. Okay, so this is your axis, this is your generator, this line, please check, generator. Okay, this is revolved like this to make this double napped cone. Okay, and we have the axis which is vertical axis. Okay, angle between the generator and this is given by the alpha. Now we'll see more angles beta also coming in the coming sections. We are making for parabola, for circle, for ellipse and for hyperbola. Okay, right, we have this, no? So we have, if you see, the first one is going to be circle. Okay, then I think we'll get here ellipse. Okay, and then here we get again parabola, and next will be your hyperbola, right? Hyperbola. Okay, so we'll see all these sections, conic sections. We'll see that their formulas, how to solve questions on them, and I've taken some questions also, so we'll solve them at the last. Okay, now if you look at the first one, which is going to be circles and ellipse, check this out. Conics as sections of plane and a right circular cone. So how do you make a plane? So you take the plane like this, and when you take perpendicular to the double napped cone in one of the section, what you get? You get this as a circle. You get this as a circle. Please check here. The condition is when the cutting plane is at right angle to the axis. Very important. Right angle to the axis. Whenever this happens, the resulting figure, a 2D shape, will be your circle. Okay. So the curve on the intersection is a circle now. Please check here carefully. This part I'm talking about. So whenever this beta value is looking as 90 degree, we call this to be a circle. Okay, but when the cutting plane is inclined to the axis, okay, not perpendicular but inclined to the axis with some angle other than 90 degree, what we get? We haven't, okay, Asha, this intersection is only possible for only one napping. Okay, only one nap, either upper or lower. We don't take both. Then you'll have an inclined circle like this. Please check, something like this. That's called as ellipse. It's called as ellipse. But this is going to be your ellipse. Please check. So plane was like this. Okay, in the beginning you were getting a circle, of course in the only one nap, either upper or lower. So when it was like this, you were getting a circle. But if it is moving like this, what will happen, bacha? You will cut. Do one thing. No, you can think of this. If you take an onion, right, and cut, okay, take any vegetable, carrot also you can take. If you cut perpendicularly, you get a circular figure, right? You get a circular salad piece. Okay, but if you cut like this at an angle, what do you get? You get a shape like this. Now you get a shape like this, right? And that will be your ellipse. It's not perfect over here, but something like this you'll get. Okay, chaliye. If you want, you can try it at home. Very safe, but be careful with the knife. Okay, chaliye. Let's begin now for the next case, where we are talking about Parabola, again in only one nap. If you take both the naps, right, you'll get hyperbola. Okay, so let's read the inclination part. The inclination increases as the inclination increases, the cutting plane is parallel to the generator. Means, please check here. In this case, the cutting plane was like this. Okay, and if you keep moving, so keep putting it like this. Basically, it was like this. Okay, it was like this. This is a generator. The plane was like this, bacha, initially. Okay, now if you keep moving it downward, 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 sometime it will become parallel to the generator. It will become parallel to the generator like this. Okay, it will be like this. What will happen in that case? Not visible, no? What will happen if the plane is parallel to the generator like this? What will happen, bacha? You will have this and this angle equal. Please check here. You will have the angles equal. I'll show you. I'll show you. In this figure, it's difficult to see. You can see it over here. Please check. This angle here, sir. This angle is nothing but angle beta, and this angle is nothing but angle alpha. They are equal because they are parallel lines. Okay, this line if you produce over here, and this line you check, these are parallel lines. So wherever this alpha beta are equal, what will happen, bacha? You'll get the figure. The cutting intersecting figure will be a parabola in nature. It will be like this, right? It will be like this. Please check. Okay, if you draw it properly, of course it will be a parabola. If you check this figure, there's a curve ending like this now, so we have the shape like this, correct? So if you remove this top part, okay, you'll have a shape of a parabola. Please check. Clear? Same goes now if you further move it, if you further move this angle, for example, in the beginning we had something like this, right? Okay, this was the plane, let's say. Yeah, so we had something like this. Okay, then move to the same parallel to the generator we got. Now if you move this line further downward, okay, you'll get something like this figure. Okay, not perpendicular exactly, but something little less than the angle. Okay, please check. I'll show you. 1 second. Yeah, something like this. If you do it like this, not perpendicular, this is a perpendicular line, but not perpendicular, something like this. What are you gonna get? You'll get two intersections, one in the upper nap, other one in the lower nap, and that will be your, check here, it'll be the figure like this, sir. That's called as hyperbola. It's called as hyperbola. Okay, please check. When the cutting plane is further inclined, it intersects both naps, and then the curve on the intersection is hyperbola. Hyperbola consists of two branches, one in the upper nap, one is the lower nap. Right? Clear? Chali. So let me just erase the extra things not required over here. All right. Clearly visible in the figure, right? Yes. Great, sir. Moving on now. So if you look at some relationship for the angles alpha and beta, what is angle alpha, bacha? Angle alpha was the angle between the generator and the axis. Okay, generator and the axis, that's your alpha. Please check. Angle between generator and axis. Okay, whereas what is beta, bacha? Beta is the angle of the plane with the axis. Okay, check here. When beta is 90 degree, what you get? You get here circle, sir. You get here circle. Okay, Acha, they've given already over here. I've taken this already over here. Alpha is semi-vertical angle, of course not the whole thing now, semi-vertical angle of the right circular cone, and beta is the angle between by the intersecting plane to the axis of the cone. Okay, whenever the beta value is between alpha and 90, it was 90, right? Now it is between alpha and 90. What happens? You'll get ellipse, bacha. You'll get ellipse. If it is equal to alpha, what will happen? You get parabola. You get parabola. Less than alpha means, what will happen? I said no, further inclined. Further inclined means it will be hyperbola, because you have to get two napping. Okay, sorry, two intersection in both the naps. Okay, so please check. Very simple things. I've given the tabulation over here. Sometime can be asked in the case of what you call MCQ. So that's why very important to know this simple small table. Okay, relation of the angles. What angles, sir? Angle made by basically half angle of the cone. So our angle between the axis and the generator, or beta is going to be the angle between the plane and the your generator. Sorry, axis. Okay. So circle is the locus. Now we'll talking about only circles. We'll go individually. We'll go from circle. Next we'll talk about ellipse. Then next we'll talk about parabola and hyperbola in detail. Let's go from the circle part. So a circle is the locus of a point. The points. What is the circle, bacha? So that, what is the meaning of locus, sir? Path. Locus means path. path is what, bacha? Means my way of going, let's say my path of going home will be certain way. Okay, I'll go first from in front of my house, take a straight of 50 meters, then take left, like that we can go. That's the path part. You know, all of you know the path. So same way, a point, let's call this tip of this pen to be a point. So this point has a path. Whenever this path is always at a constant distance from a fixed point. I repeat myself. Whenever this path, okay, whenever this point moves in a path such that every time it is at a constant distance from a fixed point. There's a fixed point over here. This is the point. Whenever it moves always at a constant distance, always at a constant distance, that is called a circle. Correct now? So this is the fixed point called as center, okay, and the path of the point will be always at the fixed distance, which is nothing but radius. Won't you all agree? Yes. So this path is called as circle. That's why I said the locus here is called as circle. Please check here. The fixed point is called the circle. Okay, please check. Okay, remains at the constant. Fixed point is called center, and this path, okay, is called as the circle. Chali? Correct now? The fixed point is called as center, and the path is called the circle, and this will be the fixed distance is called as radius. Very clear. I hope all of you are very clear with that. Now we have the standard equation of a circle. What is that going to be? X minus h the whole square, y minus k the whole square equals to r square. What is h and k? H and k represents the center. Okay, and r represents the radius. Please check. R represents the radius. This is the formula. X from there, which this is coming from the distance formula, sir. From the distance formula. Nothing big is there. Okay, very simple. From the distance formula, we are getting this statement. I hope this is clear. Okay. What next we have? Now there's a note. This is in the parametric equation form of writing the variable x, or basically the coordinate of the point on the circle. Points on the circle. Okay, so given by x equals to h plus r cos theta, y equals to k plus r sin theta are the parametric equations of the coordinates of the circle. Correct now? Any point you take in the parametric form, you'll have this as the equation. X equals to h plus r cos theta. Not clear? What do you do actually, bacha? No, please check what you do over here. If you want me to tell you that as well, I can do that. So if you take a point over here, no, and if you, this is the, let's say, radius. What do you do, bacha? You take one of the vertical component, which will be, in case of sine, if you take a horizontal, it will be r cos. There will be r cos, na? This will be r cos. This will be r sine. Correct, right? Okay, have a look. Done. Okay, not required right now. Just just know the formula. That is good enough for us. Okay, like why to confuse you a lot. This is good enough. Okay, let's move on now. Let us move on now. So now position of a point with respect to a circle. Let's discuss this part as well. So whenever bacha the point is inside the circle, what will happen? Of course, the distance Cp will be less than the radius. Doesn't it make sense? Yes, it makes sense, sir. Cp will be less than the radius. If it is on the circle, if the point P is on the circle, first point was inside the circle, so Cp was less than the radius. Next bacha is going to be on the circle, so Cp is equal to radius. And the last one is outside the circle. So what will happen, bacha, to the point, for the line Cp, it will be of course more than the radius. Okay? Yes. Chali? Done? Great, great, great. So let's move on now. Now next is your parabola. What we do in the case of parabola, sir? Remember? So in case of parabola, what we do is, the fixed point is called the focus of the parabola. So if I have to define it over here, so the distance on the, so basically the path, the locus of a point which is at the equal distance from a fixed line and a fixed point. Sir, in circle we were having only one thing. What was it, sir? It was only a fixed point. But in the case of parabola, what is there? We have two things. One is called as fixed line, other is called as fixed point. And definition is what, bacha? That the distance of the point of, basically the locus of the point, the point which is at an equal distance from the fixed point and the fixed line. And the fixed line. If you take the path of that, you'll get this path. Okay, you'll get this path, and this is called as parabola. Whereas this point becomes focus, it becomes focus of the parabola, okay, and this is called as directrix. It's called as directrix. This will be your axis, okay, this will be your axis. This point is called as vertex, is called as vertex. Please check, okay, and the line joining this point will be your lattice rectum, right? It's going to be LR. It's a rough figure, I'll draw properly, don't worry, but just giving you, just if you want to forget all of this, let's do one thing, let's erase everything else. We'll focus on only one thing that we had to prove over here, which was nothing but your distance part, okay? Let's forget everything else, okay? I'll just remove all of it. Yeah, 1 second guys. So I'll take a point over here, let's call this to point P. So basically the idea is this, if I call this to point F now, FP will be equal to this point, let's call this to be A, so AP. AP and PF are equal. Got it? AP and PF will always be equal, so forever will be equal. Do you get it? Okay, let's read the definitions that I have over here. So fixed line is called the directrix of the parabola, fixed point is called the focus of the parabola. Okay, what is there? Straight line perpendicular from the focus to the directrix is called as the axis. Here please check. Okay, great. So what do we have? The point of intersection, focus to the directrix, okay, correct. It's called as axis. This is the axis, okay. The point of intersection of a parabola with the axis is called the vertex of the parabola, this point, okay. Chord passing through the focus and perpendicular to the axis is called as lattice rectum, okay. This is the axis, this is the lattice rectum. If I draw the figure properly, please check here. So you have bacha over here, the parabola I'll write. This is the parabola, okay. This is, let's call this point to be focus now. This called to be point to be focus. This is your directrix, okay. Not clearly visible, I'll change it, I'll make it neater. 1 second. Yeah, 1 second. It'll become directrix, right? It'll be called as directrix, okay. And next you'll call this to be your, let's call this to point to be P, okay. And we have this again, as I said, P. If I call this to be A, I have AP equals to AF all the time, okay. Now this is your vertex. This point is called as vertex. This line over here, okay, is called as lattice rectum, okay, lattice rectum, and this bacha is called as your axis, called as axis, okay. Please check. All right, so let's move on now. The ratio of the distance of any point from the focus to the distance of the point from the directrix is called as eccentricity, okay. So what is it, bacha? Please check. SP to PM, SP to PM. What is SP? Acha, they have taken over here SP, right? So I can take this SP to PM, so basically they are saying this as SP, right? PM, okay. I'll change that. Let's keep the same constant, okay. I've taken this already as SPPM, no? So let me take the same constant, okay. Okay, please check. The ratio of the distance of any point from the focus to the distance of the point from the directrix is called as eccentricity, okay. So this is going to be from the focus from the directrix, so SP to PM. Please check. SP to PM will always be equal to E, sir. So basically SP to PM. What is SP, bacha? The point's distance from the focus and the point's distance from the directrix, SP to PM, okay. This is called as eccentricity. This is called as eccentricity, okay. Now this will always be, bacha, what? In this case it will be always equal, na? SP to PM is equal, so you'll have E equals to always 1 in the case of parabola. How come, sir? Remember, SP and PM are equal, so that's the definition of parabola. Distance from the fixed point from the fixed line should be always equal. That's why parabola, okay. Actually, the distance of the point PXY from the focus S is called the focal distance, of course, okay. What is there now? The parametric coordinates of the parabola is 80 square comma 280, where T is of course a parameter, okay. Let's move on now. So now we have, bacha, the forms. Please check. How will this look like? Symmetric about x-axis. How about this, bacha? Same thing but concave leftward. So this will be like this. Please check. 1 second. 1 second, I can change that. Yeah, so this will look like this. Have a look. This will be over here, right? This is the equation for the second one. Okay, and next what will happen for this one? You will have upward parabola. We'll have upward parabola for this, and for this one we'll have downward parabola. Please check. Okay, so again they've given equation of the axis will be y equal to 0 here, y equal to 0. Same over here also. What is this point, bacha? What is this line called as? Y equal to 0 only, right now? And over here what is the axis going to be? This axis is going to be x equals to 0. Same over here, x equals to 0. This is your axis. Great. What next we have? Equation of directrix, bacha. In this case, what is, where is the directrix? Over here. X equals to minus a. In this case, what will happen? Over here somewhere. X equals to a. This is the directrix. Over here, what will happen, bacha? Y equal to minus a. In this case, what will happen? Y equals to a. This is the equation of directrix. Please check. A minus a, A minus a. Okay. Vertex will be again every time 0 only, origin only, right? So we write here origin. Here also is origin, origin, and origin. Here also origin, origin. All for point is origin only. Focus will be, bacha, over here. Please check. What is the point called as? Focus, na? So a comma 0 will become in this case minus a comma 0. Okay. Over here you'll have this as 0 comma a, and this will become 0 comma minus a. 0 comma minus a. I hope this is all clear to you, right? Okay. The last one is not clear, but I hope you get it. You can see from here also. Please check. This is clear. Same thing. Okay. What is there now? This will remain same, bacha, because it's a length, right? It's a length. All is positive, bacha. So hence 4a, 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 4a. Okay. Let's move on now. Now next is the ellipse. Next is ellipse to us. So an ellipse is the set of all points in the plane, the sum of whose distance from two fixed points in the plane is constant. Basically, if I take this point P, right, over here, the point P over here, P to S, this is a fixed point. S and S dash is a fixed point. This is S dash and S, S dash and S. Okay. So basically, from the S dash and from the S, distance will be PS dash to PS. It will become PS dash plus PS. Okay. Will always be equal to the sum, right? Sum of this will be equal to, I can write this also now, A S dash and AA. Basically, check here, A dash and S dash plus, what is this, bacha, now? This case, A and A to S dash and A to S, right? Same thing, A dash to S. Okay, A dash to S. So for the same point, you can write like this. It will become basically what, bacha, what? It will become AA dash. It will become AA dash from here. Please check. It will become AA dash from here. Yes. Right? So always will be constant. Okay? Always will be constant. Have a look. Now let's go to the definitions. The two fixed points are called as foci. So S dash and S. Okay? The midpoint of the line joining the foci is called as center of the ellipse. Like we had in the case of circle. We had in the case of circle. This is your center. C is the center. Please check, everything is written over here. What else is there? The line segment passing through the foci and the endpoints A and A dash is called as major axis. This is your major axis. Please check. I hope this is mentioned somewhere. The major axis. Okay. And this will be your minor axis. Of course, if you change this to this ellipse, it will just completely reverse. In this case, this will be your major axis. Major axis. And this will be your minor axis. If you reverse the ellipse over here, all good. Okay, so this is major axis, this is the minor axis. What next we have? Please check. We have line segment perpendicular to the major axis. It's called as transverse. It's called passing through the center of the ellipse with endpoints B. It's called as minor axis. Okay, same thing. Extremities of the major axis are called the vertices of the ellipse. Please check here. So here this A dash and A and A dash will be your vertices. Have a look. Vertex and vertex. So here A and A dash is the vertices of the ellipse. Great. What else we have, sir? Okay. The ratio of the distance of any one focus from the center and the distance of any one vertex from the center is called as eccentricity. It's called as eccentricity. Okay. The ratio of the distance of any one focus from the center. So you can take any focus, okay? These are the two focus, no? You can take any one of them to the distance of any one vertex from the center You can take from either A. Why A and A dash doesn't matter? Because this is say equal distance, no? This will be equal distance, sir. It will be A and A. Check here. A dash C will be A, right? Okay. And same way, A C dash will also be A, sir. Okay, because total distance is how much? 2A. Okay. Let's move on now. So latest rectum of any ellipse is a line segment perpendicular to the major axis through any of the focus. Same thing like this. If you draw this, this L dash will be your latest rectum. This line L dash from any of the focus. Why any of the focus? Because even if you draw over here, no, it will be the same length. That's why. Whether you draw on the focus S or S dash, you'll have the same length. It's called as L dash, the latest rectum. Okay. Chaliye, and that is it. Okay. Moving on now. I've taken your what do you call, one of the features over here for all the formulas at one place. Equation when it is not at the origin. When it is origin, what will happen, bacha? Please tell me. It will become simply, sir, 0. H will become 0 and K will become 0. For the case where the ellipse center is at the origin. Okay. So it will become 0, 0. Otherwise it will be H comma K. It will be H comma K. Okay. Alright. What else we have over here? Please check. I think okay, yeah, this only. Okay, forgive me. Yeah, H comma K will be your center. When H and K is 0, it will become bacha x square by A square. What will become? Please check. It will become x square by A square plus, okay, minus na, no, plus y square by B square equals to 1. It's ellipse, right? Not a hyperbola. Okay, it's ellipse. Okay, please check. Done. What is this will be? Have a look. Plus and minus A comma 0 in this case. Please check. A comma 0 in this case. Okay. Semi-transverse will be okay. But I think this I have taken for the case of your what do you call, for the case of your please cross check, okay, once. I think this looks like for the case of hyperbola, sir. That's why I was confused, but it is incorrect. Okay, I'll make this to be, I'll just change this a little bit. It'll become, please check here. I write this as major and minor. Okay, I write this as major and minor. So I write here major, and this will become 2A. I write here minor axis. It'll become 2B. Okay. So if I write semi-major, it'll become A only. If I write semi-minor, it'll become B only. Okay. Chali. So rest all things are right. Yeah. Great. So again, please check. Correct only, right? Yeah. Now focal length is also right. Eccentricity, this will become, I have to write this. So this will be root of 1 minus B square upon A square. 1 minus B square upon A square. This is your value of E. Please cross check and let me know. Okay. Chali, let's move on now. This is a parametric form again for your ellipse. X equals to A cos theta. Excuse me. X equals to A cos theta and B sin theta. Okay. Where theta is a parameter such that from 0 to 2 pi. Theta from 0 to 2 pi. Okay. Great. Let's move on now. Hyperbola. Okay, hyperbola is the locus of all those points in a plane such that a difference in the distance, okay, is always constant. Okay, from the two fixed point is always a constant. Please check, always a constant. All right. So again over here I've given your hyperbola. Please check. There's a minus sign, of course. Okay. Great. Yeah, that's why I got to know. I have taken the, I think, table incorrect. So I've changed that, right? Everything I've changed that. Yeah. This is wrong, bacha. Yeah, please check. All right. Great. If I messed up something on the table, let me know that in the comment section. Okay. What else I have? Standard equation is going to be this, of course. Of course, sir. We know this, right? What else we have? Center will be 0, 0. If it is center, if I can take h, no, it will become x minus h the whole square and y minus k the whole square upon a square and b square, like this only. Okay. The equation of transverse axis, y equal to 0. Okay. X axis, x equal to 0, y axis. Okay. What else we have? Length of the transverse axis, 2a. For conjugate it will be 2b. Okay. So let's look at this hyperbola will be same, no? Just reverse everything. Okay. It will become 2b in this case for conjugate axis. The foci will be a, 0. The foci will be a, 0. Okay. Chaliye, let's move on. What next, sir? Equation of directives will become same thing. X equals to plus minus a by e. Okay. and vertices will be, sir, a comma 0 plus minus a comma 0. What will happen to eccentricity? It will be a square plus b square by a square. A square plus b square by a square. Simply, if I want to write like this, root of 1 plus b square by a square. Great. We have lattice rectangle length as 2b square upon a. The length of lattice rectangle will be 2b square upon a. Okay. They are the coordinates of here, or in the terms of parameter, which is nothing but theta over here. That's a parameter, right? Theta is the parameter. Please check. What else we have? Focal radii. Okay. Difference of focal radii, SP dash and SP will be 2a, and tangent of the vertices will be x equals to plus minus a. The vertical line across both the ends. Okay. Please check. This is done, sir. Now we have some questions to solve. Let's solve quickly and move on. What else we have? First question: if focus 6, 0, if focus is 6, 0, directrix is x to minus 6, then the equation of parabola is how much? Okay. Basically, they are saying that focus, right? Focus is given as 6, 0, a, 0. This is the parabola. Here 6, 0. Okay. Directrix is over here, bacha. Makes sense. Correct? Correct only, na? Please check this. We know that this and this has to be equal to each other. For this point, I take for the vertex point, this distance, bacha. If I take this to be OA and B, of course, OB has to be equal to OA, right? OB has to be equal to OA, right? Then, bacha, simply I get A equals to, please check from here, 6, right? So my equation is nothing but 4, y square equals to 4ax, 4 into 6 into x, so 24x. 24x is the answer. Option A is correct. Please check. Option A is correct. Let's move on now. Okay. If ends of a major axis is plus minus 3, 0, okay, for the ellipse, right, they're saying major axis and minor axis. So let's draw this. Okay, this is going to be 3, 0, and they've given this as minus 3, 0 works. It means my value of A is nothing but 3, right? Okay, and the minor axis, bacha, 0, 2, and it will become 0, minus 2. Okay. Find the equation of the ellipse. This is very simple. B value is 2. Right here, x square by a square plus y square by b square equals to 1. From here, what we can write? X square by square of a. So 3 square, so 9. Y square by b square, so square of 2. So 4 equals to 1. Please check. Answer is 9 and 4, right? Option is A. Please check. This also is done. Okay. Correct, no? Let's move on now. Okay. Question number 3. If we have root of 2009 upon 3 times of x square minus y square equals to 1, then the eccentricity of the hyperbola, that's much a value of E, right? Value of E, sir. Please check. Here's the formula, right? We'll have a square plus b square upon a square, na? That's the formula for eccentricity. Please check. That's the formula for eccentricity. I'll write properly. That's the formula for eccentricity. Okay. So our goal is to find what, bacha? Our goal is to find a square and b square. That's everything we need. Okay. So let's solve this. We take this equation like this: root 2009 upon 3 x square minus y square equals to 1. Can I take this inside? It'll become sir x square upon, I can take this in the denominator, no? It'll become what, bacha? It'll become 3 upon root 2009, right? And minus sign will be there. Okay, it's hyperbola. Okay, so y square, same thing will be happening over here. 3 upon root of 2009 equals to 1. Correct, right? I can take this, if you want, I can take the reciprocal in this term. Okay, both the term I can take common. Same thing is done over here. So I'm going reverse. Okay, so instead of taking it common, I'm giving it inside and then taking the reciprocal to make this in this way. Okay, so if you compare from here, what are you getting? You're getting a square value as equals to b square value. Simply we're getting this as 3 upon 2009 in the root. Is that clear? Okay, so basically a square and b square are equal. So now from here you can check what is there. E value is nothing but root of a square plus b square upon a square. So they are equal, no? I can write here simply 2a square upon a square. Cancel, cancel. I get this as, please check, root 2. Option A is correct. Option A is correct. Done. So yes, this is it, picture. So I've taken only 3 questions for this. I hope you liked it. So let's begin with the session what we have. So first thing over here is introduction. Please check. So why is the need of complex number, bacha? So far we have already done number systems, real numbers. Why complex numbers? Okay. Do you remember this quadratic equations where we used to have x square plus 1 equals to 0? Not only that, we have not only this equation, we also had more equations than that, wherever the discriminant value was actually less than 0. All this type of equations, when we said that there doesn't exist any solution for the given quadratic equation. Actually, they existed but not in the real form. Okay, for all these type of equation, the solution exists actually but not in the real form. So please check here. If you write x square equals to -1, you have answer as x equals to root of -1, which is not possible until unless I can replace this -1 by I square as -1. Now check the answer. Now this will become, so x equals to root of I square, nothing but is I. Okay, so what we actually do is, this I is called as imaginary part. Imaginary part, and this imaginary part is nothing from your a number which is called as complex number. Complex number, which has both part, actually real part and imaginary part. So far you have learnt only this section. Okay, this is the new thing. Okay, this is the imaginary part over here. So we have properties, as we used to have properties in real numbers, we'll also have properties for imaginary part as well. So we'll see that, and not actually just for the imaginary part, we'll have in general for the complex number. Okay, so basically whenever you see this kind of numbers where, well, what is that, where you have negative of root available, what happens is the number will be of a form of complex, and which will have both parts, real and imaginary. This is a very important thing to note down from here. Okay, so whenever you have seen the examples, the questions with discriminant of a quadratic to be negative, there also we can utilize this. Okay, for example, when you solve the cube root of infinity, first root of the cube root of cos. So if you take cube root now of 1, not infinity, I meant unity actually, forgive me for that. So whenever I talk about cube root of unity, okay, x cube minus 1 equal to 0 I have, bacha. So I can check, but what is x cube equals to 1? I get x equals to cube root of 1, answer is 1. So first of them is only real, but actually check here, what is the power? Power is 3. It means it should have 3 roots. No, the other 2 roots are imaginary. The other 2 roots are actually imaginary roots, and they are given by -1 plus minus root 3 I by 2. -1 plus minus root 3 I by 2. You can find that from here. Please check. You can use the formula, no, x minus 1 times of x square plus x plus 1 equals to 0. When you solve for this factor, you get x as 1, of course the first root. When you solve for the other factor, you get x square plus x plus 1. You get the x value as actually -1 plus minus root 3i, which will be nothing from, if you solve for this part, no, check here, your d will come out to be b square minus 4ac, right? So what is going to be b square, bacha? 1 square minus 4 times of 1 into 1, how much is that? 1 minus 4, how much is that? -3 less than 0. So this is the case I was talking about, that not only in this case where I square is -1, we also have the cases where discriminant is negative for quadratic equation, and there what we do is we take this root 3, and write this, sorry, not root 3, this 3, and write this as, please check, write this as 3 times of actually I square. Okay, 3 times of actually I square, and when you put this whole thing in the root, bacha, what are you gonna get? You're gonna get this as I root 3. So basically I'm taking the negative sign over here as I square and writing and then applying the root for the root d. Na? When you find the answer, you get x plus minus, sorry, you get this is the formula, right? 1 second. For the quadratic, the formula is like this, remember, minus b plus minus root of d upon 2a, na? Right, upon 2a. So if you add root d to this, you're gonna get root of 3i square. Root 3 will remain inside, you'll have I square come out as I. That's what it is here. Please check. Plus minus root 3i. Okay, so in either of the cases we have the application of complex number for us. Okay, so whenever you are able to find either directly I square equals to minus 1 is applicable, or where d is less than 0, and when we apply substituting this minus sign, basically minus 1 equals to I square like this, and then still solve this root to get the result in terms of I into some number, some real number. Okay, so that's how we make use of the complex number. I hope this is clear. Okay, I hope not complicated at all, Let's move on now. Now we have to learn the general form of complex number. This is given by, so you have a notation, you write this with the variable z written as x plus iy, x plus iy, where x represents here the real part and y represents here the imaginary part. This represents here the imaginary part. Okay, imaginary part. This clear? Okay, so like that. Now if you look at this, purely real and purely imaginary complex number, it means a number which does not have, if I talk about only purely real, let's say I talk about only purely real number, what will happen, bacha? You will not have this part. Okay, so you'll have z equals to, let's say z1 equals to only x, only x will be there. Okay, in this case what will happen, bacha? Purely imaginary, what will happen over here? There will be not any real part, so you'll get this as, let's say, iy. Okay, only iy will be there, basically 0 plus iy. Over here what is there, bacha? Only x. There is no real part, sorry, there is no imaginary part in this case. It's purely real and purely complex numbers, sorry, purely real and purely imaginary complex numbers. Have a look. Okay, now we have, if z equals to a plus ib, a and b belongs to, of course, real numbers. This a and b both parts, imaginary part or real part, will be a real number only. Okay, so also denote this as z equals to aib, okay, by any ordered pair a comma b. The complex number 0, please check here, 0 equals 0 ib, 0 plus i0 is both purely real and purely imaginary. Correct, no sir? Because 0 is, if I write just 0 as the real part, is that okay? Yes sir. How come? Because 0 is a real number, no? Right? If I write just 0 i0 as a imaginary part, okay, that also be okay, because 0 is again a real number. So I can write this 0 as, basically it can be treated as either purely real or purely imaginary as well. Okay, moving on, algebra of complex numbers. First one is addition. Means let's say I have two numbers like this, z1 equals to x plus iy, okay, and I have z2 equals to a plus ib. Then I can write which are z1 plus z2 equals to, have a look, x plus a plus I times of y plus b. Basically you add or subtract. Same thing goes in the case of difference also. Add or subtract your real part together and imaginary part together. Okay, so x plus a and y plus b. Same in the case of difference, what will happen? This will become bacha minus sign, this will become bacha minus sign. So same thing, no? This both will be same only. Whereas in the case of multiplication of two complex number, there will be different story. Have a look. You will have x plus iy times of a plus ib. What are you going to do? Multiply x and a together, okay, and then x with ib together, okay, and then with iy plus times of a and iy times of ib. Okay, so you'll have, actually please check, you'll have this as xa plus you'll have I xb. Next what are you going to have? Plus I ay or ya, and last will be bacha plus I square, I into I, no, so I square by dy. Okay, so this will become, please check, it will become xa minus, what is I square value? Minus 1, no, so minus by, and you can take here minus sign common, I common, it will become xb plus ya. This is multiplication. Okay, now next is the division. What will happen in this case, bacha? Very simple, same approach. You will have x plus iy divided by, you have, let's say, a plus ib. Okay, one thing you can do over here is rationalize or simply write this as, have a look, can rationalize this and then simplify later, or you can write this as x upon a plus ib, and here plus iy upon a plus ib, and then rationalize. You have the same result anyway, okay? Either write like this and then rationalize, or rationalize this and then identify the real and imaginary part together, okay? Done. Simple. Let's move on now. So what we have next is properties of addition and multiplication. So properties are there, please check. First property is closure property, okay? Means for any two complex numbers z1 and z2, even z1 plus z2 will also be complex, and z1 into z2 will also be complex. Clear? For any two complex number, we have z1 and z2. Even z1 into z2 and z1 plus z2 will also be complex. Okay. Moving on. Commutative bacha, yes, its property is valid. z1 plus z2 you write, or z2 plus z1 you write, both will be giving you the same result. Okay. Whether you multiply z1, z2 together or multiply z2 into z1 first, same result. So whether on addition or multiplication, the commutative property is valid for complex numbers. Okay. Next is what? Associative property. Associative property. 1 second. It's incorrect. Let me just change this part. Associative property, no? 1 second. Associative property, sir. Associative property. What is there, sir, in that? Whether you add z2, z3 together first or z1, z2 together first, doesn't matter. Sum will be same. z1 plus the sum of this two, or z1 plus z2 plus, then you take the sum of z3. Property will be same. Same goes in the multiplication first. Whether you multiply z2 into z3 together or you multiply z1 to z2 together first, doesn't matter. Answer will be the same. So both in the case of addition and multiplication, the property of associative law will be valid. Okay. Moving on. Existence of identity. Okay. So basically there will be a number 0 all the time, which when added to itself will be giving me the same answer, will be giving me the same itself. So z plus 0 will be same as 0 plus z, or simply z. Same goes within the case of multiplicative identity. What will happen in this case? You'll have 1. You'll have 1 over here. So you write z into 1 or 1 into z, answer will be z only. So both multiplicative and additive identity will be true. What is it? This is additive identity and this is multiplicative identity. Okay. Additive identity and multiplicative identity. For additive we have 0 as a complex number, and for additive identity we have 0 as a complex number, and for multiplicative identity we have 1 as a complex number. 1 can be written as 1 plus I0. 1 plus I0. Okay. Existence of inverse, please check. So for this which I have, for every z I'll have minus z. Okay, we shall make it 0. That's what is called as additive inverse. For the multiplicative inverse we have this as z power minus 1. Basically, if I have x plus iy, no, as my z, okay, what will have? I'll have this as one number like this. Please check. Iy. If you take this conjugate, you're gonna get this as x minus iy upon x square plus y square. X square plus y square. Please check. Same thing is written over here. Yeah. Check this out. X upon this whole thing. Sorry. I wrote it wrong. Okay. I wrote the final answer, bacha, actually. I wrote the final answer. Okay. So if you take the rationalization, no, you're gonna get this as a result. After multiplying with, you're gonna multiply this with this thing, x minus iy. X minus iy over here and over here as well. You're gonna get this as x minus iy upon x square, because x into x will be x square, no? And for this you'll have I square y square. I square is negative, that's why plus y square. Please check. Okay, simple things. Chaliye. Now we have integral power of I. Okay, so basically I power 0 will be 1. We know that, and we just learned right now, very important. I square is nothing but minus 1. We also have I cube. We can write this as I square into I. So simply minus I. And if you go to I power I square to I square will become I power 4. How much that will be? Minus 1 ka square. How much is that? Simply 1. Okay, so please check. Like that we have the integral powers of I. Okay, now identity is related to complex numbers. Same thing we've learned in algebra as well. Please check x1 plus y1 the whole square or z1 plus z2 the whole square. What we have? The formula a square b square plus 2ab. Same goes in the negative sign. Here we have minus 2 z1 z2. Whole cube is also there. Same formulas for whole cube and goes here with plus and minus. This is the formula of a square minus b square. This is the most useful one. Highly useful in the questions because we're gonna use this for rationalization of the denominator. Okay, basically we remove the complex part, the imaginary part from the denominator with the help of this formula over here. Let's move on. The modulus and the conjugate of a complex number. First is modulus, which this is how we find it: square root of the real and imaginary part the square. Sum of the real part square and imaginary part square. So let's say the number is given over here a plus ib, right? A plus ib is there, so a is the real part, b is the imaginary part. You take square of both and add them under a square root. That will give me the value of modulus of z, basically the magnitude of the z. Okay, great. Conjugate of a complex number. So let's say I have a z like this, a plus ib, no? So conjugate will be z bar, okay, and it becomes equals to a minus ib. A minus IB. That's simple, sir? Yes, that's simple. That's simple. Okay, let's move on now. We have a complex number z is purely real if what? Please think about it. If I'm writing bacha z bar equals to z, what it means? Okay, think about it. What is the value of z bacha? A plus IB. This is nothing but A minus IB. Their equal means bacha what will happen? Only if this B is 0. Only if this b is 0, sir. Correct or not? Otherwise, how can it be equal to each other? I have a minus ib over here. I have a plus ib over here. Can they be equal to each other? If you put them equal, what will happen? You will not get this to be cancelled. Of course, only possible if b is 0. If b is 0, what will happen, bacha? You will have only a left in the number. Hence, it is purely real. If b is 0 means a has to be the only number which is present in the form of a complex number. Hence, purely real. Okay. Whereas in the case of complex number, purely imaginary, you'll have z bar equals to minus z. Think about it. If I write bacha again z as a plus ib, I get z bar as what bacha? A minus ib. How can they be equal? How can they be equal if this a is 0? If this a is 0. If you put a as 0, what will happen? You'll have, please check, you'll have z as ib and z bar as minus ib. What it means? Please check. It becomes z equals to z bar. Sorry, minus of z bar, sir. Z equals to minus of z bar, sir. That's what it written over here. Please check. Done. Okay. Properties of modulus. Okay. So modulus of z is 0. It means real part is 0 and imaginary part is 0. Not 1. Both has to be 0. Okay. Both has to be 0. Z modulus or z bar modulus or simply minus z modulus will always be same, because you have a square root of a square plus b squared, no? So whatever is there will become again positive when squared. Okay, then the range of this real value of z bacha will be from minus z to plus of z. Correct. Same goes over here for imaginary part, minus of z to plus of mod z. Okay, look up. Now what we have next? Z times of z bar will become equal to z square. Correct. Think about it. We have this as a square plus b square times of a square plus b square. Whether you take plus or minus doesn't matter, no? Think about it. If I write this as z square, sorry, z mod of z, what will be mod of z bar? It will become a square plus minus b square. It will become same thing, na? It will become, I have a root of a square plus b square the whole square only, which is nothing but, please check, it will become simply bacha mod z square. Please check. Correct, na? When this is what bacha? This is your mod z, na? This is mod z. What is this? Mod of z bar. Yes or no? What is mod of z bar? A plus ib, right? The z bar will become conjugate. So a square is the real part square. The imaginary part is minus b. I've taken the square of that. It will become again b square only, no? So I'll have same thing multiplied to each other. So I'll write here as whole square. What is that going to be? Mod z the square. Please check. Same goes the property over here as well. Okay. Same in the division also, but it has to be non-zero. Z1 by Z2 will become mod of Z1 by mod of Z2 but mod of z2 has to be non-zero value. Okay, again bacha, you have the formulas over here. z1 plus z2 the whole square become z1 square. If I have two complex numbers z1 and z2, if you take sums whole square, you'll get this as z1 square, z2 square, and 2 times of real part of z1 into z2. If you take here minus sign, what will happen, sir? It will become bacha minus 2 times of real part of z1, z2. Okay. Now if you add them, if you add the first two, what will happen? This will be cancelled. Sorry, this will be cancelled. You have only 2 times of z1 square plus z2 square. z1 square plus z2 square. Okay. Next, what we have? az1 minus bz2 the whole square plus bz1 minus az2 the whole square. Okay, a and b are real numbers. Okay, it will become equal to a square plus b square times of mod of z1 square plus mod of basically z2 square. Okay, I have taken a question on this property today, you'll see. Okay, let's move on now. So properties of conjugate. Okay, properties of conjugate. Now conjugate, basically z bar to bar will become z itself. Okay, z plus z bar will become bacha 2 times of real part of z. Think about it, x plus iy and x minus iy. Add them, you'll have only 2x. That's why 2 times of real part of z. Whereas you can take subtraction, it will become 2 times of imaginary part of the I times of imaginary part of the z. I'm talking about subtraction over here, right? So you'll change the sign, no? You'll have minus and minus, it'll become cancelled. Okay, I have over this side as, sorry, plus now 2 times of iy. So that's why I written here 2 times of I imaginary part of the z. Okay, please check. What next we have? Z equals to z bar means z is purely real. Okay, this I already discussed, no? Purely real and purely imaginary concepts. I did discuss this. Okay, z bar equals to z means real. If I have z bar equals to minus z means purely imaginary. Okay, z times of z bar bacha becomes equals to the real part of z the whole square plus what is this? Imaginary part of z the whole square. Correct, no? Remember this, y square. Okay, got it? How can we get this bacha? From the formula x plus iy into x minus iy. X plus iy into x minus iy. Please multiply. X into x is x square. We get this as I square y square. I square is negative, that's why plus y square. Clear now? Okay. Again, the property we have, if you have let's say a difference or addition of two of your what do you call complex number, you apply conjugate to that, it will become simply conjugate of the first plus minus conjugate of the second. Okay, same goes in the case of your ratio or the division, same goes in the case of your product. Okay, and you have again similar thing. If alpha is fz and you're looking for alpha bar, you can write this as f of z bar. Of course, a has to be any complex, alpha has to be any complex. Please check. Done. Okay, simple things. Now Argand plane and polar representation. Argand and plane and polar representation. Please check Argand plane bacha. How can I write this, sir? Please check. So if I have in the Argand plane, what we do know in this case, we take this to be x and y. No, usually we call this to be bacha real axis and we call this to be imaginary axis. Imaginary axis. Okay, imaginary axis. So if you take a point over here with the coordinate, of course, x comma y, what will happen now? You'll have this length as the magnitude of the complex number. Okay, so this will be your x, which will be a real value. Okay, and this will be your y, which will be a imaginary value. It will be a imaginary value. Okay, so how will you write this value, bacha? This will become actually root of x square plus y square with the help of Pythagoras theorem. And isn't this the magnitude of the point or the number, complex number? So basically I can write complex number as x plus iy, and this mod will become bacha root of x square plus iy square. So basically mod of z is nothing but distance of that particular point from the origin. Okay, in the Argand plane. Okay, correct. Chaliye. Now cube root of unity, please check. The roots of z cube, as I said, I told you this, we got this value now, remember, minus 1 plus minus root 3 I by 2. One of them is real, right, which is nothing but simply 1. Other two are called as imaginary roots. So first of them is omega, other is omega square. So basically when you take the plus sign, you take this as omega, and this is going to be minus sign over here as omega square. Okay, Please check. So there are some formulas over here. One of the properties, 1 plus omega square will be 0. Of course, please check if you add them, what are you going to get? I have 1 over here. If you add these two, you get minus 1 by 2 plus minus 1 by 2. It becomes minus 1. Add these two. It becomes minus 1. There's a plus 1 over here, which means 0. Again, you have plus of this, minus of this will be cancelled again. So you have the answer as simply 0. Again, you have omega cube will be equal to 1. Omega cube will be equal to 1, sir. Done? Alright. Let's have a look. Moving on now to the questions. Let's solve the questions and complete the session very quickly. x1 and y1 be the real numbers. If z1 and z2 are complex numbers, I said no, there's a property I have taken like this. Basically, there it was a z1 minus b z2 actually. The whole square was there, remember? This property was there, bacha. Yes? Okay. 1 second. bz2, the whole square, and same thing was here. The answer was, remember, a square plus b square times of z1 square plus z2 square. Remember this? Okay. So in this case, what we're going to get? Please check. You get this as, have a look. This property I'm talking about. Oh, where is this property, sir? This property. Please check. Okay. So if you check this out, I think it should be z1 actually. I've taken here as x1 y1. It should be z1, no? Okay, they have given the z1 value, no? They've given z1 value. They've given this as 4 actually, sir. Even instead of giving you the real number value, they've given mod of z1 and mod of z2 as 4. Okay. So please check, this will become, bacha. Okay. This is, I've taken ulta actually in this case. So it doesn't matter. We'll keep this a1 as x1 only. x1 square plus y1 square. The real numbers I'll keep as it is. Okay, not x1, y1. And this, please check here. It will become, bacha, 4 square plus 4 square, na? So 16 plus 16, how much is that? It remains as it is, x1 square plus y1 square. I get this 32. Option is A. Please check. If you want to get expanded also, not a problem. If you want to get expanded also, I get x1 z1 minus y1 z2, the mod, right? And then I get this side as, please check, y1 z1 plus x1 z2 the whole square. If you want to expand it here, you get x1 square z1 square plus y1 square z2 square minus 2x1 y1 z1 z2. Okay, same goes over here as well. You get here plus y1 square z1 square plus x1 square z2 square. Okay, and you get here plus 2x1 y1 z1 and z2. This will cancel this part over here. If you take this common, you have x1 and you have z1 and z1 over here. Club this together and club these two together. You get this as, please check, you get this as z1 square times of, okay, you have what, bacha? Please check, you have x, what I've taken. Okay, I want to take z1 common, no? I want to take actually x1 common. Do this, it will become, bacha, z1 square equal to x1 square plus y1 square, okay? And over here I'll have y1 square common. It will become, sorry, y1 square, no, z2 square, no? Excuse me. It will become, so z2 square times of x1 square plus y1 square. Have a look. From here you can get the same result what I've written over here. Please check. Answer will be option A. Okay, not confusing at all. Very simple question. Very, very simple. Okay, what should be the, if you know the property, you can get the answer without, you know, doing any of the effort. Otherwise you have to do the multiplication. What should be the positive value of p, so that the magnitude of this, let's call this to be z1, is nothing but twice of, let's call this to be z2. This is, sir, z1 actually, twice of mod of z2. Write this now, it will become, sir, root of 3 square, now, so 9 plus p square actually. Okay, and I get this side as 2 times of, what is this, 9 by 16 plus p square, now, again in the root. Now square on both sides, you get this as 9 plus p square equals to 2 square will become, bacha, 4, and you'll have what, this is 2, right, over here. 1 second. You have 2 over here, no, in the multiplication. So right here 2, it will become bacha 4, the root will be again cancelled. You will have 9 by 16 plus p square. Check this out. You get here 9 plus p square equals to, cancel this, 4 4 is 16. You will have 9 by 4 plus 4p square. Move this on this side and this on this side. You get here 9 minus 9 by 4 equals to 3p square. Okay. So I get here 16 minus 9, no, 36 minus 9, okay, upon 4 equals to 3p square. So 25 upon 4 equals to 3p square, correct? Right? So I get this as 27, sorry, not 25, 27 actually, excuse me, 27 sir. 16 minus 9 will be 27, no? Yeah. So 3 9s are 27. I get here 9 by 4 equals to p square. It means p equals to root of 9 by 4. So p equals to 3 by 2. P equals to 3 by 2. Option C is right. Option C is correct. Have a look. Done. Simple question. Extremely simple. Okay. Let's move on now. Alright. What we have now is, if z1 minus 1, z minus 1 upon z plus 1 is purely imaginary now, then which is true? Let's have a look. So sir, let's take z equals to, again same thing, x plus iy. Okay, so this will become bacha z minus 1 upon z plus 1 will be nothing but, have a look, x plus iy minus 1 upon x plus iy plus 1. Okay, so I can rewrite this as, please check, x plus iy minus 1 upon x plus 1 plus iy. See what I'm trying to do over here? X plus iy minus 1 divided by x plus 1 times of, sorry, plus iy. I'm trying to make this rationalization with the help of this term a plus b. So it will become, so x plus 1 times of, sorry, minus actually iy upon x plus 1 minus iy. What I get now? Have a look. So I'm getting over here the numerator as x into x bacha, so x square, x into 1, so plus x, x into minus iy, so minus x y times of I. Okay, next what? I multiply iy with this, you get here plus I xy, iy with this, again iy with 1 bacha will become plus iy, and iy with minus iy bacha will become minus I square y square. Okay, now I have to do with minus 1, you get here minus x, sorry, minus x, you get here minus 1 and plus iy divided by, please check, you get this as x plus 1 the whole square. Okay, and you get minus iy the whole square, minus iy the whole square. Have a look now. So I'm getting this same thing, z minus 1 upon z plus 1 as the numerator. Please check, something interesting coming up. Have a look. So I'm getting here, sir, minus xiy common, same thing is over here, plus sign getting cancelled. Okay, one more thing is there, plus x minus x also is cancelled. Okay, all right, what else I have? Nothing else. All right, sir, yeah. So I'm getting here, please check, x square, what is this going to be? Please check, what is going to be this part? Minus I square y square, no, it will become plus y square actually. How come, sir? How come, sir? Please check. I square is minus 1, no? So minus 1 into minus 1 will become plus only, right? So plus y square I get. Then I get here minus 1. Then I get here plus 2iy. Plus 2iy divided by the denominator. But I have x plus 1 the whole square. And same thing I'll have plus y square. Same thing, no? I square y square, it will become minus sign is there, so it will become plus y square. Okay, now check this out. I can expand this as x square plus y square plus, sorry, minus 1 is there, no? Minus 1 is there, excuse me. Minus 1 upon the same denominator, x plus 1 the whole square plus y square, plus I get 2iy upon x plus 1 the whole square plus y square. They are saying that this is purely imaginary. This is purely imaginary. Means bacha, this part has to be equal to 0, sir. It means x square plus y square minus 1 upon whatever it is, okay, has to be equal to 0. Put it equal to 0, bacha. I can cross multiply on this side. I get this as x square plus y square minus 1 equal to 0. It means bacha, x square plus y square equals to 1. It means, sir, please check here. It means, sir, x square plus y square, the root will be equal to actually root of 1, and this we know is nothing but mod of z. Mod of z becomes equals to actually 1 only, right? Correct, no? Got it? Have a look. Have a look. I can write it better. Mod of z, right? So I get this x square plus y square. I'm taking root on both sides. I'm taking root on both sides. It will become root of x square plus y square, root of 1. Root of 1 is 1, and I get x square plus y square as simply mod of z in the root. Okay. So answer is option number B. Option number B. Please have a look. It's an excellent question. It's a very, very, very good question. Okay. Let's move on now. Have a look. Chali. On a Argand plane, cube root of unity represented by. Okay. So we have three roots now. Please check. You have z1 as 1. I can add 1 plus I times 0. Okay. Then I have z2. Remember this z2 was nothing but, I have over here this as bacha, have a look, minus 1 by 2 plus, if I take, let's say, 3 by 2, root 3 by 2, and z3 if I'll have minus 1 by 2 minus I times of root 3 by 2. If you plot these points, correct, no? I can write this as ordered pair, right? It will become 1, 0. It will become, bacha, please check, minus 1 by 2, comma, root 3 by 2. And this will become, so, minus 1 by 2, comma, minus root 3 by 2. I get 3 coordinates. If I point them on the number line, I actually get this as vertex of equilateral triangle. How can you find this? Find the distance between them. Okay. Plot this on the number line. You get this point as somewhere 1, 0, and this the other points. You'll find the distance over here. You'll get this as equal. Will be equilateral triangle. Please check. Fourth is done. Answer is option A. Fifth one. Okay, the last question from this topic. Z equals to minus 3 minus 2i. Then the mirror image. Okay. This is real axis, imaginary axis. Okay. I get here minus 3 minus 2i somewhere over here. Please check. This is a point A. Minus 3 minus 2. Image of this about x-axis. So somewhere over here we'll have a dash will be bacha what? Please check. Sorry, minus 3 minus 2, no, it will not be over here. Excuse me. It will not be over here. It will be on the third quadrant, right? I misjudged it. Okay, sir. So you'll have A over here as please check, minus 3 minus 2. So what will have the A dash somewhere over here? A dash. It will turn out to be minus 3 and plus 2. Right? Minus 3 and plus 2, sir. Okay. That's the image of the point A. So your answer will be minus 3 plus 2, which will give me, please check here, minus 3 plus 2i cap. Minus 3 plus 2i cap. Answer is what, bacha? C. Answer is C. Have a look. Done. Okay. This is it from this chapter. Okay. So we have completed our complex number. Okay. Let's move on. So with this, I'm going to end the session today. I hope you had fun. I hope you solved all the questions. Right now, this is it for the session. I hope to see you again very soon. Till then, take care. Bye-bye.